Ever feel like you're writing the same lines of code over and over, just slightly different? Or stare at a massive script and wonder how you'll ever debug it? You're not alone. This kind of repetitive, tangled code isn't just annoying. It's a productivity killer, a bug magnet, and a nightmare to maintain. It makes your projects brittle and your life as a developer harder. By the end of this video, you'll not only understand what functions are, but more importantly, why they exist and how they'll fundamentally change how you write clean, efficient, and scalable code. The problem: code repetition and spaghetti code. Let's be real, when you first start coding, you just want to see things work. So you copy-paste a lot. We've all done it, but that quickly leads to a mess. Imagine you need to change that tax rate from 8% to 10%. You now have to find every single place you wrote 0.08 and update it. Miss one, and you got a bug. Real talk, this is where projects spiral. The solution: what is a function? Okay, so a function is essentially a reusable block of code that performs a specific task. Think of it like a mini program within your bigger program. You give a name, tell it what to do, and then you can call it whenever you need that task done. It's like writing a recipe. You write the recipe once, the function definition, and then anyone can follow those steps, call the function, to bake a cake. You don't rewrite the whole cake recipe every single time you want a cake, right? Wild, right? Why use them? Reusability and the dry principle. The biggest win with functions is reusability. Instead of copy-pasting that tax calculation code, we wrap it in a function. This embodies the don't repeat yourself, dry principle, a cornerstone of good software engineering. Now, if the tax rate changes, you update it in one place, inside your calculate total function. That's it. No more frantic searching, no more missed updates. This drastically cuts down on potential bugs and makes your code way more robust. Honestly, I think the dry principle is underrated when beginners start out. Inputs and outputs, parameters and return values. Most functions aren't static. They need information to do their job. We pass this information in as parameters or arguments. Think of it as giving ingredients to your recipe. The function then processes those ingredients. And often, functions need to give something back after they're done. That's where return values come in. A function can perform its task and then hand you a result. It's the output of your mini program. Without return, a function usually just does something, but doesn't hand you a direct answer. Makes sense? Still with me? Good, because what we've covered so far is just the groundwork. The real power of functions lies in how they let us build complex systems out of simple, manageable pieces. Get ready, because this is where coding stops being a chore and starts becoming art. Scope: local versus global variables. Quick dive. Quick side note: when you declare variables inside a function, they typically live only within that function. This is called local scope. It means variables created inside Greet can't be accessed outside of it. This is a good thing. Trust me, it prevents accidental interference and keeps things organized. Hot take: while global variables exist, generally, you want to avoid them. They can lead to unpredictable behavior and make debugging a nightmare. Keep your variables as local as possible. Some devs swear by global variables for certain configs, others hate them. My take: functions help you avoid needing them almost entirely. Abstraction and modularity, managing complexity. Okay, so beyond just avoiding repetition, functions are fantastic for abstraction. What's that? It means you can use a function without needing to know how it works internally. You just care about what it does. Think about driving a car. You don't need to understand the combustion engine to get to the grocery store. This leads directly to modularity. Functions let you break down huge, daunting problems into smaller, manageable chunks. Each chunk, function, handles a specific part of the overall problem. This is a game changer for large applications and teamwork. It's the difference between trying to build a house with one giant block of concrete or with individual bricks. Real-world impact, collaboration, and maintainability. When you work on a team, functions become even more critical. If Alice is working on a user login function and Bob is building product search, they can work independently without stepping on each other's toes. As long as they agree on what information each function takes and returns, it's smooth sailing. And for the long haul, maintainability is king. When a bug pops up, instead of sifting through thousands of lines of code, you can often narrow it down to a specific function. This makes debugging a surgical strike rather than a frantic search. Plus, when it's time to add new features, you can often just add new functions or modify existing ones without breaking everything else. It's truly a game changer for the longevity of your code. Beyond the basics, functions as first-class citizens. Okay, one last advanced thought. In many modern languages like JavaScript, Python, or even C#, functions are first-class citizens. This means you can treat them like any other value, pass them as arguments to other functions, return them from functions, or assign them to variables. This is a powerful concept that unlocks incredibly flexible and expressive code patterns. Quick tangent: this whole functions as values idea is what powers so much of modern web development, especially with frameworks like React or Node.js. Callbacks, event handlers, array methods like map and filter, they all lean heavily on functions being first class. It's what makes your code reactive and dynamic. It's a slightly denser topic, I know, but stick with me, it's worth understanding the why. Let's recap. Functions solve code repetition and prevent bugs by centralizing logic. They promote reusability, adhering to the critical dry principle. Parameters and return values enable dynamic, flexible function behavior. Scope keeps variables organized and prevents unintended side effects. Functions facilitate abstraction and modularity, making complex systems manageable. They are crucial for team collaboration and long-term code maintainability. The key takeaways: always look for repeated code blocks and encapsulate them in functions. Name your functions clearly, describing what they do, e.g., calculate tax, not process stuff. Understand the difference between console.log and return. It's fundamental. Keep variables local to functions whenever possible to avoid global headaches. If this helped you understand why functions are absolutely essential, consider supporting the channel. Every bit helps keep these videos free for everyone. Drop a comment with your thoughts or your favorite function analogy. I genuinely love hearing from you all.